Okay, the 2.A.2 homework. This is the gas laws homework. Starting with 5.17, we're supposed to identify which of the diagrams represents, first of all, substance is above its boiling point, which means it should be a gas. So the picture that represents the molecule spacing and attractive forces in a gas would be letter D. Below the boiling point, but above the freezing point, would be a liquid, but you would see a few evaporated gas molecules above the liquid, so that's why letter B is the better choice on that one. 5.18 has different diagrams of a gas that is being different changes, compression, temperature changes, etc. Placed upon it. The first one is asking what it would look like if the pressure triples at constant temperature and moles. Well, if the pressure goes up, the volume should go down, and the molecules should move closer together, which would increase the darkness of the color, and that's represented in letter B. Temperature doubles at constant pressure and moles. It would mean the volume would go up, but the molecules would spread apart, so that looks like letter A. If the moles doubled at constant temperature and pressure, the volume would double, but with extra moles to fill the extra volume, you would still have the same amount of color. And if the temperature is halved, but the pressure is quartered, first of all, halving the temperature is going to cut the volume in half, and then quartering the volume is going to multiply quartering the pressure is going to multiply the volume by 4. So actually cutting the volume in half, then multiplying it by 4 means the volume doubles. But the molecules will still have the same spacing. So we're looking at letter A again. Okay, moving on to number 520. On 520, we have a Boyle's law problem, P1V1 equals P2V2 at constant temperature in moles. We have a gas at 5.3 atmospheres at a certain volume, and we want to know what its pressure is going to be if its volume is 1/10 of the original volume. So we'll just call it V1 and 1/10 V1. If I multiply both sides by 10 over V1, I get 53 atmospheres equals P2. 5.24 is a Charles law problem. Volume 1 over temperature 1 equals volume 2 over temperature 2. Volume 1 is 9.6 liters. Temperature 1 is 361 kelvins. Make sure you change to kelvins. Volume 2 is 3.4 liters. Temperature 2 is our unknown. Multiply both sides by T2. Divide both sides by 9.6. Multiply both sides by 361. You get T2 equals 128 kelvins, which is minus 145 Celsius. Okay. Now we have 5.26, which says that 1 volume of chlorine and 3 volumes of fluorine make 2 volumes of product. Remember, for gases at constant pressure and temperature, that the same volume of gas has the same number of particles. So I can use this 1:3 ratio as the mole ratio. Cl2 plus 3F2 is going to make 2, well, it would make 2 ClF3s. 5.32, Pivnert. Pressure equals nRT over V. These are the numbers given in the problem. 6.9 moles. 0.08206 is R. 335, when you convert to kelvins, divided by 30.4 liters, gives us a pressure of 6.24 atmospheres. .40, we have 88.4 grams of carbon dioxide. Do a quick conversion to moles. That's 2.01 moles. Plug it into Pivnert. The problem says 1 atmosphere. Actually, it says standard temperature and pressure, so the pressure would be 1 atmosphere times volume equals the moles times R. Standard temperature is 273 Kelvin. Divide both sides by 1 atmosphere, you get 45.0 liters as the volume of this gas. 5.44, find the molar mass. So remember in class we had derived that molar mass equals dRT over P, and of course density is mass over volume, so that becomes mass times RT over P times volume. Just using the numbers from the problem, 7.10 grams, 62.36 for R, 317 for T, 741 torr for pressure, 5.40 liters. Do all the math, cancel the units, you get 35.08 grams per mole. Okay, finishing up. 5.50. We have SF4. We want to know if that's the molecular formula or just the empirical formula. So we're going to use that same formula. Molar mass equals MRT over PV. Use the numbers given in the problem. 0.100, 0.08206, 293, 1.02 for pressure, 0.0221, that was 22.1 milliliters, which is 0.0221 liters. Plug it all in, you get a molar mass of about 106.66 grams per mole. If you add up the SF4 formula, you get 108.02 grams per mole. And so it looks like a 1-to-1 ratio there. So SF4 is both the empirical and the molecular formula of this compound. 5.58 is a gas stoichiometry problem. Involves 2 HCl's and 1 CaCO3 yielding CaCl2 plus water plus CO2. Use Pivnert to find the moles. Plug in the pressure, the volume, R, T. I got 0.0284 moles of carbon dioxide. Calcium carbonate and carbon dioxide have a 1-to-1 ratio, so that's 0.0284 moles of calcium carbonate. Change it to grams. I get 2.84 grams of calcium carbonate. Now it was part of an impure sample that had a total mass of 3 grams. So 2.84 divided by 3 times 100 is 94.8% calcium carbonate. So it was impure by about 5.2%. 5.66 is a partial pressure, Dalton's law of partial pressures problem. You got a total pressure of 745. You've got the first noble gas is 368 millimeters of mercury. You've got the water vapor pressure, because they were collected over water, is 28.3 millimeters of mercury, plus the pressure of the neon. Solving for the pressure of the neon, you get 348.7 millimeters of mercury, or 349. 5.102, we've got the two bulbs, one of helium and one of neon. We're going to open the valve between them, and the gases are going to mix. But at the same time, each gas's volume is going to increase because now it's going to be able to flow into the other container. And so it can occupy both containers. The two containers together, 1.2 liters plus 3.4 liters, will have a final volume of 4.6 when they become one container when the valve is opened. So starting with the helium, 0.63 atmospheres in a 1.2 liter bulb. When it now is allowed to expand into both bulbs, it will be P2 and 4.6 liters. Divide both sides by 4.6, you get the pressure of the helium once it has expanded into the entire container is 0.16 atmospheres. Likewise, the neon is at 2.8 atmospheres in a 3.4 liter bulb. But then when it expands into 4.6 liters by being allowed to also occupy the other bulb, you get pressure of neon to be 2.1 atmospheres.